Welcome back to our series on trigonometry. We're going to be dealing with trigonometric functions of any angle. Now, when we had our first few sections that we were covering, we dealt with acute triangles. They were right triangles with one angle that we were focusing on, and we were doing the 6 trigonometric functions. Now, what if we have non-acute angles? Let's imagine our triangle centered at the origin, where we have our initial side on the x-axis, and then we have that ray opening up. We can use this theory or this idea to calculate the trigonometric ratios for non-acute angles. Using this triangle that we have to the right, where one corner where the hypotenuse and one of the legs comes together at the origin 0, 0, and we have another point labeled P that is xy, we could find this distance r, right? Where using the distance formula, that's just the distance of x1 minus x2 squared plus y1 minus y2 squared. Or you can do x2 minus x1, whichever order you want. Doesn't matter because you're squaring it. So let's say we have x minus 0 squared plus y minus 0 squared. Then r is going to be equal to the square root of x squared plus y squared. But we also know that from the Pythagorean theorem, right? 2 legs squared added together is the length of the hypotenuse squared. We can take these original trigonometric functions that we had and use them with these new definitions of x, y, and r rather than opposite, adjacent, and hypotenuse. So instead of sine being opposite over hypotenuse, we can say that the sine of theta is y over r. For cosine of theta, that is going to be adjacent over hypotenuse, or x over r. And then tangent is going to be opposite over adjacent, or y over x. Cosecant is the reciprocal of sine, so that's going to be r over y. Secant is the reciprocal of cosine, which is r over x. And cotangent is the reciprocal of tangent, or x over y. Using this idea where we have some angle theta in the standard position, where we've got this point on the terminal side. Remember, our initial side is our x-axis. It's centered at the origin. So our terminal side is this blue line, where r is the distance to xy from the origin. So it's just the square root of x squared plus y squared. We then have these new definitions for our trigonometric formula. P is on the terminal side of angle theta and not at the origin, which means that r is not going to equal 0. Otherwise, we wouldn't have an angle. It would just be a dot. The signs of the trigonometric function then depend on where you are in the quadrants, because this is now saying that theta is not just going to be contained in quadrant 1, which is all positive. So we're going to have P could be in quadrant 1, 2, 3, or 4. And we know that in quadrant 1, x and y are both positive. But in quadrant 2, x is negative and y is positive. In quadrant 3, both x and y are negative. In quadrant 4, x is positive and y is negative. So looking at the sine, cosine, tangent, cosecant, secant, and cotangent, depending on where you are in the quadrants, the signs might change. So we can create a graphic that shows what the signs are for each of these. So think about this. Let's talk about the third quadrant. So in the third quadrant, both x and y are negative, which means in quadrant 3, the sine of theta is going to be a negative over a positive r. Remember, r is always positive because it's representing the distance of that ray. So we're going to have a negative over a positive, which is going to be a negative. So I could say that another way to write that would be to say that the sine of theta is going to be less than 0 because it's negative. Now the cosine of theta is also going to be less than 0 because, again, it's going to be a negative over a positive. But notice that the tangent is going to be a negative over a negative because both x and y are negative in the third quadrant. So a negative over a negative is actually a positive, which means that the tangent is going to be greater than 0. And using reciprocals, the signs are not going to change for reciprocals. So that means that the cosecant of theta is going to be negative, the secant of theta is going to be negative, and the tangent of theta is going to be positive. And you can use that same idea to get the values for sine, cosine, tangent, cosecant, secant, and tangent in the second quadrant and in the fourth quadrant. which are shown here in this table. We have special values for the axes. So quadrantal angles are angles that have their terminal side on the coordinate axes. For instance, in between quadrant 1 and 4, that would be 0 or 2 pi. In between quadrants 1 and 2, that's 90 degrees or pi over 2. In between quadrants 2 and 3, that's pi. In between quadrants 3 and 4 is 3 pi over 2. So those have special values because at those points, we are dealing with a value being 0. One of the coordinates is 0. So on the x-axis, y is 0, and on the y-axis, x is 0. One way that books will describe or authors will describe what the values are for sine, cosine, tangent, and so on for the quadrantal angles is they'll pick just some random point. But it doesn't actually matter. You can just use a negative x and a positive x and so on. So for instance, let's say I had pi over 2. That's going to be where x is 0 and y is just some y value. So if I was to do r, remember that r is equal to x squared plus y squared. Well, in this case, x squared is 0 because it's at the it's anywhere on the y-axis, so x is in the middle. R is y squared, or r is equal to y. So if I was to evaluate the sine of some theta here at 90 degrees, that's going to be the y value over r. Well, y is equal to r in this case, so that's just going to be 1. The cosine of theta is going to be the x value over r, or 0 over r, which is 0. And then tangent of theta is going to be the y value over x. Well, in this case, x is 0. And so tangent is actually undefined at pi over 2. And then you can do the same for secant, cosecant, and cotangent. But you can just pick a coordinate with x and y, and then 0 being the other one, because r winds up being either y or x for those particular problems. A reference angle is an acute angle formed by the terminal side of theta and the horizontal axis. So for instance, I might have some angle in quadrant 3 that winds up being obtuse, but the reference angle is going to be an acute angle. Remember that acute angle is less than 90 degrees. It's going to be the terminal side and the horizontal axis. So it's always in relation to x. So it's the angle formed by the terminal side here and the horizontal axis. So it's going to be this angle right here. Now, if I was in the second quadrant, that would be the terminal side is red here, and the horizontal axis is still yellow, so the reference angle would be here. If I was in the first quadrant is already an acute angle. So that's just going to be the reference angle itself, but again, in relation to the horizontal axis. And then if I was in the fourth quadrant, in relation to the yellow, the horizontal axis would be here. So your reference angles, I always like to think about, like, if I was to make a butterfly out of this, the wings span out to the side. Your reference angles are always either above the x-axis or below the x-axis, but connected to it. So that helps you kind of think about where your angle is. And the way you calculate your reference angle depends on the location that you're in. In quadrant 1, you're dealing with angles that are from 0 to 90 degrees, and I'm not including 0 or 90 because those are the axes. In quadrant 2, you have angles that are 90 degrees to 180 degrees. in quadrant 3, you have angles that are 180 degrees to 270 degrees. And in quadrant 4, you have angles that are 270 degrees to 360 degrees. Now, if I wanted to think about that in terms of pi, that's going to be from 0 to pi over 2, pi over 2 to pi to 3 pi over 2, and 3 pi over 2 to 2 pi. So in order to figure out what this angle is here, the green one, that is almost to 2 pi. So what we can do is you can take 2 pi minus that angle of theta, and that is your reference angle. Because you're actually trying to figure out this angle plus what gets you 360. If you're in quadrant 3, you're going to do the angle minus 180 because it's the leftover portion taking away that upper side of 180 degrees. Quadrant 2 is going to be 180 minus that angle because that's the portion left. Because you're thinking about things that are supplementary. And then in quadrant 1, it stays the same reference angle. So here are the rules for this. The reference angle in quadrant 1 is equal to the regular angle, the actual angle that you're given. The reference angle for quadrant 2 is equal to 180 degrees minus the angle, or pi minus the angle. The reference angle in quadrant 3 is going to be the angle minus 180 degrees, or the angle minus pi. And the reference angle in quadrant 4 is going to be 360 degrees minus the angle, or 2 pi minus the angle. So notice that quadrants 2 and 4, you're taking the 180 or the 360 minus the angle, and in quadrant 3, you're starting with the angle. Continuing our trigonometric functions of any angle, you can find the value of a trig function of any given angle based on using a reference angle. So remember, we've got this drawing of the x-axis and the y-axis. And then whenever we have some sort of reference angle, quadrant 1, quadrant 2, quadrant 3, and quadrant 4, intentionally trying to draw them not equal because it's just any angle here. So these would be the reference angles created as they are in relation to the horizontal axis. And I can create a right triangle from any of those points. And then based on that theta, these are not all the same theta, obviously, because they're different angles. Based on that theta angle, you've got your R values. I should be labeling these R1, R2, R3, R4. You've got your X values, you've got your Y values for any of these in the quadrants. And so what you do is you're going to evaluate these functions using the reference angle. So you determine the reference angle, and then you use the sign based on the quadrant that you're in. So again, in the third quadrant, cosine and sine would be negative. Tangent and cotangent would be positive based on what we did earlier. If you recall the Pythagorean identities, the reciprocal identities, and the quotient identities, we can use these identities to find values based on the numbers that were given. But remember, you have to look at the quadrant that the angle is in. And so you could use, let's say you were given secant, you could find cosecant, but you have to make sure that the sign is the right sign. You could use the Pythagorean identity, but you would have to make sure that the sign is the right sign. So it's just super important that you pay attention to the information that you're given.